Hello, welcome to my channel. So in this video I'm going to discuss my BRC interview experience. So before going to the interview questions, I would recommend you to note some points. So before the starting of your interview, you have to verify all your original documents from a counseling committee. So there will be a counseling committee which will verify all your documents. So you have to be available there with all your original documents. And after that, you will be called by interview committee for the interview. And also at the start of your interview, you have to hand over all your documents to the committee so that they will know about you. And so my suggestion is to put all your documents in a file which contains a transparent envelope. So transparent envelope. So you should buy a good file. Now let's start with my interview questions. So there were three members, and they sent me to the board and asked me to write Maxwell's equations. So I wrote the Maxwell equation. So you should keep one point in mind, that you should not say like del dot E. It should be like divergence of electric field is equals to charge density divided by epsilon naught. Divergence of magnetic field equal to 0. Curl of electric field is equals to rate of change of magnetic field. So you should be like, it's not saying like mathematical formulae. And some expected questions are they can ask from you. These were not asked from me. It's like, what is divergence, what is curl, how Maxwell's equation will modify if magnetic monopoles exist. So you can look for the solution of answer of these questions. Now they asked me to draw a glass cylinder and bound a copper wire over the cylinder, and suppose alternating current is flowing through the wire. So this is solenoid, and they asked me the magnitude and the direction of magnetic field at the center of the solenoid. So, and the next question was, is there any electric field outside the solenoid? And if yes, how induced electric field magnitude will vary with distance r from the center of the solenoid? So these were the questions asked by one of the member of the committee, and these are actually electrodynamics questions. Now next member of the committee asked me the questions from quantum mechanics. So he asked me to draw 1D potential box, infinite potential box, and write its wave function and energy eigenvalue. So you know the formula, you can write it. And then he asked me to draw a wave function for the ground state psi1. So you can see this is the ground state wave function for infinite 1D potential box, where L is the width of the box. So he then asked what does a wave function signifies. So you know, wave function does not have any physical significance, and the square of the modulus of the wave function give the probability density function. So next was like draw psi1 and square of modulus of square of psi1 on the same plot. So you have to be careful that this probability density function will be smoother than its wave function. So you can draw it. You should try this. And next question was to draw ground state wave function for the finite potential box. So you know, finite potential box, this is the finite potential box. So V naught. Okay. Then he asked me to this, like the ground state energy eigenvalue for the finite potential box, is it larger or smaller than the as compared to infinite potential box? So I was stuck at that point, and they gave me the hint. Like he said me to use Heisenberg uncertainty principle. So sometimes they will help you if you are desperate about this question. They will try to help you. So the committee is somewhat helpful. So they help me to find the answer. Now the third member asked me about the nuclear physics. So moving to nuclear physics questions. So he asked what happens to a free neutron. So free neutron, it is unstable, so it decays to proton, electron, and an antineutrino is emitted out. Then he asked me, like, can you draw the energy spectrum of beta particles emitted? So in beta decay, the electrons emitted are of continuous energy. So the spectrum is continuous. So you have to draw this plot. This plot you have to draw. Then he asked why energy spectrum is continuous, and then which physical quantities are conserved in a neutron decay. So in this neutron decay, what physical quantities are conserved? So the energy, angular momentum, charge, these physical quantities are conserved, and also the lepton number, the quantum number, lepton number is also conserved. It's a quantum number which is also conserved. And then he asked how many types of radioactive decay are there. 3 types of radioactive decay are there. And explain radioactivity decay law, what is half-life. And at the last, the tricky question of my interview, and they were trying to distract me. They were checking my confidence, so they may do with yourself also. So you should be careful. So if you are confident about your concept, you should not be distracted. The question was, suppose there is one radioactive atom. So what will happen to it after one half-life? Will it decay or not? Answer us in terms of 0 or 1. So this is a statistical phenomena. It's very probabilistic. So we can't say that it will decay or not. So it's probabilistic. We can't say about whether the atom will decay or not. So this was the tricky question and the last question of my interview. And so I will thank for watching this my interview experience video, and you may subscribe. So thanks.